Hello and welcome to our first video in this C Nuggets series. So this is not a tutorial on the C programming language. Instead, I'm going to share some experience and features of C that comes in handy when you are building real-world applications. And in today's video, I'm going to talk particularly about macros. And so because I like to use examples to teach, I'm going to start off by creating a simple C program, and then I'll explain the concept with this program. So let me create a file called main.c, and then I'm going to open that file. Okay, so I'm going to put in a very simple C program that doesn't do anything useful, but it serves the purpose for the explanation that I want to give you in this video. So I'm going to start off by saying define, let's say A, and then I'm going to put 5 in there, and then I will come and create a main function. So int argc, and then char pointer v. Okay, so we are going to talk about macros. And before I go ahead to explain what macros are, I need to let you understand one thing that makes the C or C++ programming language unique from all other modern programming languages. And it is about the fact that C and C++ has a pre-processing step before the compilation actually happens. This is different in many ways to a lot of the modern programming languages out there, because for them the compiler sees your source code directly for most of these programming languages out there. But for C and C++, we have the phase that is called the pre-processing phase. And what basically happens there is it allows us to generate code before we pass on the generated code to the compiler. And so the process of compilation, a part of the process is your C source code goes through the preprocessor, and then the preprocessor produces what is known as a translation unit. And it is this translation unit that goes into the compiler for compilation. And what this means is that we are able to write some code in our C source code or C source file that is not seen by the C compiler, but the preprocessor is going to perform something we call macro expansion. That is the focus of this video. So it will perform macro expansion, and after it is done with that, that is when we are going to the C compiler is going to see the translation unit that is generated. So the way we use the preprocessor in the C compilation process is through these directives called macros, okay, or preprocessor directives, and one of them is a macro. So over here I said sharp define, and that is every preprocessor directive starts with a sharp or the pound character. So to create a macro, I basically say sharp define, and then I give the macro a name and a value. Now this is not a variable in your C source code. The truth is macros are not valid in the C grammar. So the compiler will not take this code here, sharp define A5, as a valid C code. It only works because the preprocessor does its macro expansion before feeding into the compiler the translation unit after it has done substitution. And I'm going to show you how you can see the output of this preprocessor stage, and then you get to know which code actually gets to the C compiler, and it's also going to help you to understand how these macro stuff work. Okay, so I'm going to create a variable. I'll say int a, let me say int x is equal to a, and I'll just return 0. I'm not going to print out anything because I don't want to import stdlib. I want everything to be minimal here just for the sake of understanding. So I'll go ahead and save this file. Okay, now I have saved the file. Let me open it just so you see the code in there. On my right hand side, I'm going to use the GCC compiler to be able to run this source code through the preprocessing phase, and then it will just spit out the output of the preprocessing phase, and you see what happens. So to do that, I basically say gcc, and then it has this minus e flag, and then I'll say main.c. So see what's going on in here. I said define a5 and then int x is equal to a. Mind you, this a5 is not a valid C code, but during the macro expansion phase, the preprocessor will take it is basically going to substitute every occurrence of a with the value that we gave it here. Okay, so that is the reason why now in the generated code you can see that int x is equal to 5, even though in the actual source code I said int x is equal to a. So this is a demonstration of the fact that before compilation the preprocessor actually steps in and does these macro substitution for us. So it is not a valid C code. See that in the generated code that actually gets to the compiler, there is no sharp defined a5 here. So it's basically going to do a substitution. It's like a is a placeholder. It is not technically a constant in C, it's a placeholder in your source code, and the preprocessor is going to replace every occurrence of a with a value 5, and this is what we have here. Okay, now that we understand this idea of a macro, and we've also seen how we can instruct the preprocessor to spit its output instead of going ahead to pass it on to the compiler, I'm going to show you one more type of preprocessor, a macro that is known as a function like macro. So we can also create something that looks like a function but is actually not a function. What you need to keep in mind is substitution. Okay, so I'm going to create a function like macro that takes in two parameters a and b, and what actually happens is it adds a to b. Okay, so up here I said sharp define add ab and then a plus b. Now inside the code, what I'm going to do here is I'll say x is equal to 2, and I'll say int y is equal to 3, and over here I'll say z is equal to, I'll say int z is equal to add, and then I'll pass in x and y. Okay, now I don't want you to be confused about this code once again, because sorry, I'm trying to save my file. Okay, let me open it again. Yeah, so I have a function like macro that I call add, and it's basically taking two parameters a, b, and then it's going to return the summation of a and b. So in my main function I call add, and then I pass in x and y, which are variables that have been defined and assigned values up here. Then I store the result into z. Okay, now I want you to imagine what type of code the preprocessor is going to generate when it sees this add called in main. Do you think it's going to create a valid C function and then call it, or is going to do substitution? And if you guessed the answer is substitution, then you are right. The way we can see that is to basically come in here and then instruct the compiler to preprocess our main.c file and stop after the preprocessing phase. And the way to do that is to use the minus capital E flag, and then let's see what happens in here. So you can see that this is the actual code that we have in our file, and then we have sharp define add ab, and then it returns a plus b. Now let's see what happens in the generated code. You can ignore all these ones up here. We'll talk about them in other videos, but just focus on the generated code, which is down here. So what's happening here is you can see that we had int x is equal to 2. We also have int x is equal to 2 here. We have int y is equal to 3. We have int y is equal to 3. And then we have int z is equal to add x, y. And then over here we have x plus y. So what is actually happening is the preprocessor during the macro expansion phase is basically doing a substitution. Okay, so We said add AB. So whenever you see add AB, we want you to replace it with A plus B. So what happens here is when the preprocessor sees add XY, it is basically the same as saying put X plus Y here. So this is more like just in place substitution that is going on in here, and it does not generate um, it doesn't create actual C functions that are valid as far as the C grammar and semantics are concerned. So this is one cool thing that I think we have learned today, and thank you for watching. I will see you in the next video.